Hey everyone, so I just wanted to do a quick review of the problems we did for the test review relay and make sure that you all are ready for our tests tomorrow, half your grade for Unit 2. Let's see if we can get to the first question. All right, write an explicit formula for the sequence defined by the recursive formula. So, u sub 0, this is going to be our y-intercept. And if we are subtracting 11, if our rule is subtracting 11 each time, then that's going to be our slope. So pretty easy. You can write it as y equals, and if my slope is negative 11, x plus my y-intercept is 6. And I'm going to use point slope or slope-intercept form. Obviously, because I have the slope and I have a y-intercept. You could also have written it as y equals positive 6 minus 11x, or even y equals 6 plus negative 11x. Okay? Any of those three ways would work. Don't make it too hard on yourself. Let's see, what was our second question? Write an equation for a line with slope 1.5 and y-intercept that is negative 3. So obs y equals 1.5x minus 3. You could say y equals 1.5x plus negative 3. You could also switch it around. You could say y equals negative 3 plus 1.5x. Any of those ways are a correct way to write that equation. Let's see. Question 4. Okay, the inconsistent set of systems of equations here is going to be C. And the reason why is if we combined these two, if we added these two equations, negative 4x plus 4x is 0. Positive 4y minus 4y is also 0. So if we added those, if we just added these straight up, if we combined our x's and then we combined the y's, this whole side of the equation would be 0. The other side of the equation, 4 plus 4, would be 8. So what you're left with is 0 equals 8. Is this true? No, this is not true. It is a false statement. So there is no solution. Or, like this question is calling it, it's an inconsistent set of equations. Now, on the other hand, guys, if you want to just take it up a notch, if it had been, this is not the way it was, if it had been maybe 8 is equal to 8, or even 0 is equal to 0, and that last statement was true, then instead of having no solution, it would have had an infinite amount of solutions. Okay, so not just the one where they cross, but an inconsistent would have no solution. What's next? Oh, writing an equation for a line of best fit. I wonder, so the easiest thing to do, I wonder if I can do a line on here, is tools, options, insert. I'm going to pause while I look, see if I can draw a line here. Well, I don't know, guys. If there was a way to do it on here, I am not going to have enough time to figure that out. So let's just say I want to choose 2 points to create a line of best fit. And remember, a good line of best fit is going to have about half the points on one side of the line and half the points on the other. I feel like if I drew a straight line through those 2 points, that would be pretty well. Like if I had used the pen instead, I think that would have worked out. You see where I'm going with this pretty well. So what I'm doing is I'm using this point, and we're going to have to estimate here, and this point. So let's see, 20, 40, 65. So I have 1 point that is about 165 I decided to use, and 1 point that is about 11,325. Okay, and I'm just estimating here. Okay, so I find the slope, so I'm going to do y2, which is 325, minus y1, which is 165, over x2, which is 11, minus 4. I know it's going to be a positive slope because I can see it. So 11 minus 4 is going to be 7. So I have a slope of 7 on the denominator. And 325 minus 165, I think I'm doing mental math here, so if I did that wrong, 160. So 160, that's kind of a weird fraction. It doesn't mean much. So I'm going to go ahead and do the division. 160 divided by 7. I'm going to use the calculator. 160 divided by 7. So approximately 22.86. So I'm going to say approximately because I rounded. Oh, I forgot already, 22.86. There's my slope. And my y-intercept, I'm just going to estimate maybe at 80. I'm going to make this my y-intercept. I think that would have been good. So I can write my equation, which is y equals 22.86x plus 80. That's going to be a pretty good line of best fit, I think. I could have put it into point slope form, you guys. I could have put it in. I just guessed on the y-intercept, but I could have said, hey, I don't want to guess on the y-intercept. I want to do point slope form. So I could have put my slope out here, and then x minus 4. I'm going to pick the point for 165. So x minus 4, and then plus 165. And that would be point slope form. And my point slope form, if I simplified it, would give me a different, although I bet it would be close, a different answer than, look what I did, I put plus 8. How many of you guys were screaming about that? Might be a different one. Let's do that and see. This would be 22.86x, y-intercept is what I'm talking about. This would be approximately minus, let's just say 89, because 4 times 22 is going to be 88. And then actually let's do, well, I guess we should just use the calculator. 4 times 22.86, 4 times 22.86, 91.44, 91.44, plus 165. So this negative 91.44 plus 65, that's going to be the actual y-intercept if I use this point, which will be minus 165, 73.56. So actually, I wasn't too far away from that, was I? If I did point slope form, my y-intercept would have been 22.86 x plus 70, whoops, my calculator, 73.56. Okay, either way, I just wanted to do some explaining here. Don't forget, what does the slope of this line mean? It means that $22.86, that's how much money she's putting into this savings account every month. And the y-intercept, the 73.56 or the 80 if I was just estimating, that is going to be the amount that she started with in her bank account. Okay, but you guys have been pretty good at that. I'm not too worried about that. Here, okay, so we come down to our first systems of equations, and on this page, I asked you guys to just put each equation into standard form, and we'll use the matrix on the calculator, What I mean by standard form is the x, the y, and the z all need to be on the same side like it is already for this one. okay? So let's say for the first question we have, I'm just going to rewrite the first one. It's negative x minus y minus 3z equals negative 9. Now let's do the second one. The second one has basically what I'm trying to do, you guys, is I need to move this negative 3 over, because it has an x, over to the other side of the equation. So when I do that, it just changes the sign. That becomes a positive 3x. There's no y in this one, so I'm going to put plus 0y plus z, it's already on that side, equals what's still left over on the other side, which is negative 1. Okay? And then for the last one, I already have a positive x on the side. I want to move the y over, so I'm going to subtract 5y because it was positive on this side, but when I move it over to the side, it becomes negative. And then it's a negative z, so when I move it over, it's going to be plus z equals, and I'm going to leave that 23 on that side of the equation. So when I put it in my matrix, you have to make sure that I've done this correctly. So let's do yellow. X is yellow. I have x, x, x. Good, it's all in a row. Let's make y green. Y, 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 it's all in a row. And then z can be blue. Z, 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 it's all in a row, so I know that that's correct. And then one more. Our answer on this side is pink. So everything's in a row. This is exactly what I wanted. So I'm going to put it in the calculadora. And just like the notes on the wall, we do second matrix. The first time we get there, we arrow over to edit, enter. This time I have, it's going to be a 3 by 4 matrix. Okay? So let's put it in. My first one is going to be the first yellow x, which is negative 1. Okay? Now it's the y, so I'm looking at the first green y. It's also a negative 1. Remember, in the matrix, you only put in the coefficient. You do not put in the variable. Z is negative 3, and my answer is negative 9. Okay, second row. My x is positive 3. I don't have to put a positive, obviously. My y is 0. I do have to put that 0 in there. That's why I wrote it that way. Z is just positive 1. And then negative 1 is on the other side of the equal sign. Last row, so my last yellow x is just positive 1. And then my green y is negative 5. My blue z is just a positive 1 blue z. And the answer is 23. Now, don't forget, this is the weird part. Once you enter it in to the matrix, to save it, you have to quit out of there. Okay? And then you have to go back into the matrix. But this time, instead of going all the way to edit, you only go to the second one, math, and we arrow all the way down to get to oops, oh, you guys, RREF. Enter. We've got to go back in one time. So this is telling the calculator what we want it to do to the matrix, and the last time we go back in, we have to tell it which matrix we want it to do it to. So obviously I put it in A right here. So I just choose A. I don't move right or left at all. I just choose A so that it says, oh, okay, that's the one I'm going to use is A. I hit enter, and there's my answer. It says that 1, since my x's were first, that 1 is going to be, that here is going to be, 1x is going to be negative 2, because they're in the first row there. And then the 1 is in the middle row here. That's my y. So 1y is negative 4, and 1z is 5. So negative 2, negative 4, 5. And when we write it, we're going to say negative 2, negative 4 in alphabetical order. 5. That's all you have to do for that. I'm going to pause this really quick, write the rest of the answers just so you can check your answers. All right, you guys, so I highlighted in alphabetical order the answers in orange, obviously X, Y, Z. And then above it is just how I rearranged the equation so that I could use the matrix on the calculator.